Welcome to the Infinite Jungle. On today's show, I'm going to be talking about all core developers consensus call number 135. It was a call where developers talked about their preparations for Pectra and specifically their preparations for PeerDAS, which they have recently decided to include in the Pectra upgrade and has created some concerns around the increasing scope and complexity of the Pectra upgrade overall. So we're going to talk about the discussion and the debate that had been had on ACDC 135. But before we get started, a quick programming note about this week's shows. Usually we have 2 episodes that go out per week, but this will be the only episode that goes out this week. So buckle in. We're going to be talking about ACDC 135 and for what you can do on your spare time on the Wednesday, where usually the episode is published. It's actually a holiday in the U.S. It's the Juneteenth holiday. So for that day, instead of listening to this podcast, you can spend that time with maybe friends or loved ones. So before we get started, the other thing that we'll do, as per usual, is get started with a quick show disclaimer. I need to remind you to please refer to the disclaimer linked in the podcast show notes and note that none of the information in this podcast constitutes investment advice, an offer, recommendation, or solicitation by Galaxy Digital or any of its affiliates to buy or sell any securities. All right, on ACDC 135, before developers went into their progress on Pectra, they spent some time giving 2 very quick announcements. The first announcement was that the Ethereum package kurtosis module would be migrated from oversight and management and development by the kurtosis team to the Ethereum Foundation, specifically a team within the Ethereum Foundation under the developer operations team called ETH Panda Ops. They're a team that is dedicated for testing that emerged. ETH Panda Ops became a group of developers within the Ethereum Foundation, primarily during the time of the merge when there needed to be quite a bit of intensive testing efforts dedicated to making sure that upgrade went well. And the kurtosis module that will now be overseen by the ETH Panda Ops team is the module that developers have used quite heavily already. This is a software package that developers use to spin up Ethereum testnets. And not only does this package spin up the testnet, but it also spins up necessary tooling for monitoring and tracking that testnet. And so it's a really important tool that developers will continue to use quite heavily. And in this migration process from having it overseen by the kurtosis team to now the Ethereum Foundation, there may be differences in links for where that package is hosted. Various redirects are currently being built. So for any users out there that have been using that package, please note that now further iterations of that software will be coming out from the ETH Panda Ops team as opposed to the kurtosis team. So that was the first announcement. And then the second announcement was by Ethereum Foundation Protocol Support Lead Tim Byko, who had mentioned this on the prior ACD call last week, but now he's created a draft proposal for his new for the new labels that he'd like to implement on EIPs, Ethereum Improvement Proposals. The 3 labels that he wants to formalize is the scheduled for inclusion label, considered for inclusion, and proposed for inclusion, basically identifying what stage of this EIP, what stage is this EIP in? Is it just proposed for an upgrade? Is it being considered for an upgrade? Or is it finally scheduled? And as I mentioned on the Infinite Jungle show last week, I don't think that these labels are going to be helpful. I think the time spent debating on what the label of a EIP is could be better spent talking about the merits of the EIP, talking about the implementation work that has happened on that EIP, and really whether or not that EIP is going to be ultimately included in an upgrade or not. Most of the, whether an EIP has the label of being CFI'd or not, doesn't help the EIP's case for whether or not it gets included into an upgrade ultimately. So the amount of time spent labeling these EIPs with labels that don't actually really matter at the end of the day, I think the time could be better spent identifying other properties or aspects of an EIP's progress that are a bit more objective and forward-looking to what suggests that the EIP will actually be included in an upgrade or not. But I digress. We're not going to get into that because it's not actually that important. The most important part of the call was really about developers' implementation work with PeerDAS. So first, let's talk about the core Pectra EIPs. The core Pectra EIPs that are being implemented on Ethereum include some pretty major changes to Ethereum's validator dynamics, to Ethereum's, for other aspects of Ethereum's core protocol. And PeerDAS is a code change that will only impact Ethereum's networking layer, the way that Ethereum nodes validate and propagate data through the peer-to-peer networking layer of Ethereum. It doesn't change the core protocol, the core rules of the Ethereum network, the Ethereum blockchain. So on the topic of what will impact the core protocol of Ethereum, the core Pectra upgrade itself, developers are preparing for the next DevNet. They had successfully launched DevNet 0, but it was quite a janky testnet full of lots of bugs, and developers are getting ready to launch the next iteration of the Pectra DevNet. And this iteration, DevNet 1, is going to be based on new specifications. We talked a little bit on a prior Infinite Jungle episode about how these upgrades are tested. And for DevNet 1, there's going to be a new set of code specifications that client teams will then implement into a new client release. So developers talked about the next major specs released for the consensus layer of Ethereum, because this is the ACDC call, focused primarily on consensus layer progress and development. Next week, we'll have the execution layer call. But for the consensus layer side of the upgrade, and this upgrade is called Electra, the major release that's going to be coming up is version 1.5.0 Alpha 3. And developers are really putting in their finishing touches on those specs. There's a few parts of the specs that developers need to hammer out still. There's questions about whether or not those specs should include support for things like validator consolidation triggered by the execution layer. There was some talks around data formatting that developers resolved on this week's call. So once the latest and the new version of Electra specifications are out, client teams have said that they should be able to put out a release within 1 to 2 weeks of the specs being finalized, and thereafter test all of those releases on DevNet 1. So progress is being made. Pectra is slowly but surely coming together. And that was the state of affairs for Pectra. Moving on to PeerDAS, which, as I mentioned, is the networking change, a major networking change coming to Ethereum that is supposed to enhance Ethereum's data availability capacity, the ability for Ethereum to verify and propagate and act as this data availability layer for Layer 2 rollups. When large amounts of data are submitted to Ethereum, that's quite a heavy load on nodes to be able to validate and process all of that information. And, of course, store it then on the network as well. But this mechanism of data availability sampling, basically not having to require nodes to download the full amount of data, but rather sample different parts of it, and through some math that is beyond my pay grade or beyond my educational level, that through probability and through mathematics, sampling that data, nodes are able to have 99.99, near 100% certainty that the full data was submitted, and verify that data and propagate it around. So PeerDAS is quite a major change to Ethereum's networking that is upcoming, and it seems now to be the headliner for Pectra. There was months in which developers really spent time on what core Pectra EIPs should be included in the upgrade and not. But very recently, developers have decided to include PeerDAS as well into the Pectra upgrade. And while this is a networking change, this does appear to be the headlining feature of Pectra now. And on the latest developer call, developers really talked about many different aspects of how PeerDAS will be tested. Developers are very adamant that they want it ready for the Pectra upgrade. So, being able to implement it simultaneously or shortly after the other Pectra EIPs are activated on mainnet. And we had talked on the prior Infinite Jungle show about how the testing for PeerDAS would be a little bit different from the other Pectra EIPs. It would be activated on a different epoch than the other Pectra EIPs. So you'll see on devnets and testnets the Pectra EIPs activated, and then say the networking change through PeerDAS on a later activation epoch. Now, developers had a few breakout calls since then, just primarily to focus on PeerDAS development, and there's been some changes on how developers are planning on working on PeerDAS. And the sum of what they're talking about, basically the major takeaway, is that PeerDAS is going to be developed even more separately than the other Pectra EIPs. So not only is it going to be activated on a different epoch, but it may just be tested on entirely different testnets, on entirely different devnets. Basically, developers will move forward with implementing PeerDAS on the state of Ethereum that has already been activated, that has already been finalized through the Deneb upgrade. Deneb is the latest upgrade that has gone live on Ethereum. That is, the most recent, network-wide upgrade that has happened on Ethereum, the most recent code changes that have been finalized and is live on Ethereum mainnet. And PeerDAS will be implemented as if those are the only code changes that have happened. This is so that PeerDAS can work, PeerDAS developers working on PeerDAS can work on a more stable foundation of protocol code than, say, if they tried to implement PeerDAS and Pectra EIPs simultaneously. Developers had talked on the latest call about the difficulty around trying to identify a bug if both were being implemented on the same time. At the same time, is this a networking bug or is this a bug associated with the core Pectra EIPs? So the core Pectra EIPs, of course, will also be developed and tested on top of the Deneb upgrade, as will PeerDAS. And at a later date, once both code changes, once both implementations are more stabilized, that's when developers will try and do the merging work, the rebasing work to make sure that PeerDAS works on top of the Pectra EIPs. And there was some pushback from developers on the call of why not just simply do the heavy lifting now and rebase and continue to work on both simultaneously, activate them on the same test nets, work on PeerDAS on top of the Pectra EIPs. But again, for the reasons of the Pectra scope and Pectra EIPs continuing to change and shift, it sounded like it would actually slow down the work for PeerDAS quite a bit if PeerDAS was amalgamated with the other Pectra EIPs. So one of the big kind of confirmations that came out of this week's call was that PeerDAS would be developed in its own kind of timeline and on its own networks, on its own dev nets. And at a future date, developers would identify when would be a good time to try and merge those two together. So PeerDAS and Pectra EIPs are going to be developed in parallel still, and PeerDAS does appear to be probably the headlining feature of the Pectra upgrade. Which is why another big part of the way that the Pectra EIPs and PeerDAS, the interdependencies between the two, another major point of discussion around this ongoing development work for the two was about changes to the blob count on Ethereum. So as I mentioned, PeerDAS is a networking change, doesn't necessarily change the rules of the network. But with PeerDAS, the core protocol of Ethereum will be able to be a lot more free, a lot more lax around certain rules limiting how many blob transactions can be added to a block. Blob transactions are these special types of transactions on Ethereum designed to store temporarily large amounts of arbitrary data. And because of the limitations around Ethereum's, around the nodes that support Ethereum, we have a set limit of a target of 3 blobs per block. I think with a maximum of 6 on Ethereum, and the price of the blob transactions does fluctuate depending on the demand for blobs, and to ensure that that target is continually met per block. But with PeerDAS, if PeerDAS does get activated, then in theory, the network should be able to handle a lot higher number of blobs per block. But the change, the ability for developers to increase the blob count on Ethereum, that does require a change to the protocol rules. And it may require some pretty invasive changes to the way that to the way that block rules work. So let me divide this down into two different questions that was raised on this week's call, and that I thought the person who was chairing the call, Ethereum Foundation researcher Alex Stokes, summarized quite nicely. The first question is, right now, the blob count is hard-coded into the execution layer. It requires an execution layer code change. You need to change, that 3-6, the target of 3, maximum of 6 numbers to a different constant. But in the event that PeerDAS works and most of the consensus layer changes that support higher numbers of blobs on Ethereum, assuming that all of that works, then developers may want to remove that hard-coded constant from the execution layer altogether, such that the maximum amount of blobs, the target number of blobs, is actually dictated by the consensus layer rather than the execution layer. And so removing that hard-coded limit from the execution layer means that there needs to be a way for the consensus layer to communicate to the execution layer of Ethereum, hey, these are the new rules for for the number of blobs, the target number of blobs that should be added to a block. So that's a change that developers aren't sure of how exactly should be made. There's multiple different ways to go about doing this. And the second thing that was initially mentioned by Ethereum Foundation researcher Dankrad Feist was around gas computations. Gas is a unit of measurement on Ethereum. It measures how much computational resources a certain action requires on Ethereum. So, sending a certain amount of ETH from my wallet to another person's wallet requires a certain amount of computation, and there's a constant gas, a number, it's X amount of gas that transaction requires. But if I was coding a smart contract that is going to also be a lending protocol and has multiple different, triggers multiple different actions on the network, stores a bunch of code on Ethereum, the calculation of gas, how much gas that requires, is going to be a lot higher. And now the number, the amount of gas that is required for a blob transaction, that's fixed. The price, the gas price is boundless. The gas price is constantly changing. And the gas price is basically what the network determines. It should be the conversion between gas and ETH. So how much should one gas unit cost in terms of the native asset of Ethereum, which is Ether? And that gas price changes every single block, depending on the amount of block space that's used up. And the gas price is quite volatile because demand for Ethereum block space is quite volatile. And usually, the units in terms of converting gas into ETH is actually, converting gas units into Gwei, which is 1/1000th of an ether, 1 ETH. And so, if you continue to convert that back into USD prices that maybe, you and I listening to this pod are more familiar with, that's really how you compute, how much does a transaction cost on Ethereum. So while transactions on Ethereum, sending a transaction on Ethereum can cost, anywhere. It can change on a day-to-day basis in terms of how much USD you're paying, how much ETH you're paying to send over that transaction. The computational resources that's required for that transaction to be processed, as measured in gas units, doesn't change. But of course, if you change the gas the blob target or the blob limit, you are going to change the maximum amount of gas that's going to be included in a block. And every single block on Ethereum, there is a block gas limit. And the way that gas is computed per block is quite important to the network, to the protocol, to ensure that the computational resources of the network is not being overloaded. Again, as I said, the network actually computes what the price of gas should be based on how much block space is utilized, and that block space is dependent on how much gas is used per block. So it has ripple effects. And the biggest point of this conversation is that changes to the blob limit on Ethereum will also impact gas computation. And these are changes that developers need to consider and need to make changes accordingly, update accordingly, so that gas computation for blocks continues to happen in a correct way. So lots of different ripple effects of changing the blob target, which is why the other major question around PeerDAS development is, if PeerDAS is ready in time for Pectra, should developers couple PeerDAS with an immediate change to the blob count, to the blob number per block? And the testing team of Ethereum, from the Ethereum Foundation, the ETH Panda Ops team, was saying that it's quite risky to couple both together. One of the DevOps engineers, Barnabas, had mentioned that Pectra in and of itself as an upgrade is just becoming far too large. He had said, quote, "The point is we have so many EIPs, and I feel like we just keep shoveling more and more things, and it's never going to end. So we have to draw some line somewhere. And I think shipping PeerDAS and increasing the blob count is just not something we can do in the next year and a half testing-wise," end quote. So he's expressing basically that the scope of Pectra is continuing to change, and adding in a blob count change on top of PeerDAS is just going to be too much. But another argument from one of the other developers on the call, Francesco, was that what is the point of really, trying to get PeerDAS into Pectra if it doesn't provide material benefit to changing or to improving Ethereum's data availability capacity. If you implement PeerDAS in Pectra, but you don't couple it with any changes to the blob count, then effectively the cost of data availability, the ability for rollups to commit data down to Ethereum, is the same. It's unchanged. Sure, there's more efficient ways to sample the data on the networking layer, but it doesn't actually change the cost of data availability for layer 2 rollups, in which case maybe it would be better to allow for more time to prepare the PeerDAS upgrade and not try and activate it along with the Pectra EIPs, rather activate it at a time when PeerDAS can safely be coupled with an increase to the blob count. So that was another kind of counter argument. And to that, another kind of pushback from the testing team, this time by ETH DevOps engineer Perry. One of the things that he had mentioned was around his experience testing blobs for the Denkun upgrade for EIP 4844. And he mentioned that when they were testing blobs on DevNets for Denkun, the testing environment and the simulations that were had did not perfectly map out to what they actually ended up seeing on Ethereum mainnet. He said, Jayanthi said, quote, "We did do a lot of great 4844 related testing, but the way blobs played out on mainnet is not a one-to-one analog on how it played out in testing. We do see weaker nodes having issues. We do see timing games being played. And that's the main reason why even if we simulate a perfect world in which PeerDAS, along with the blob increase, does work in all of our devnets, it doesn't actually mean anything to mainnet. And that's my main argument for why we should probably do things step by step rather than all at once," end quote. And now to this, another pretty important counter argument that was shared by one of the Ethereum Foundation researcher, Ansgar, who was saying that an increase to the blob count would be fine and should be coupled with the PeerDAS activation. Ansgar mentioned the fact that when developers are testing PeerDAS, they have to set a value for the target blob count and limit anyways. And it doesn't necessarily make sense for developers to just use the same numbers as what's being used on mainnet. There's not an entirely strong rationale to do that unless developers plan on activating PeerDAS in such a way where it does uphold the current, 3.6 constant values. And if PeerDAS for some reason goes wrong, the network can then fall back to EIP 4844 rules and still continue to uphold that 3.6 limit. But that's increasing complexity for PeerDAS in and of itself to create such a fallback mechanism. So if there isn't such a fallback mechanism and developers are going to have to choose a value anyways for testing PeerDAS, why not just choose a value that will support and that will utilize the data availability sampling to its potential, which is a number significantly higher than 3.6. And Dietrich's, or Ansgar, sorry, I keep saying his last name because that's how I write these call notes. I use people's last names instead of their first names because it seems too personal. But on the pod, we can be a lot more casual. So Ansgar was saying that to the point, though, of increasing complexity in Pectra, to the point of just concerns around the risks of packing in too many changes all at once in one upgrade, he said the better solution would not be to prevent a change to the blob count along with PeerDAS, but rather simply split Pectra into two different hard forks. And this is an idea, and this is a plan that developers had talked about in prior calls. And it seems like, based on this past week's conversation, there is a higher likelihood that Pectra may become two separate hard forks on Ethereum, and that the subsequent upgrade that was supposed to happen after Pectra, the Osaka fork with the Verkle upgrade, that could actually become not the next immediate upgrade after Pectra, but the second one after the second version of Pectra goes live. So lots of kind of important developments, I think, that are starting to shift the sentiment in developers thinking around the Pectra upgrade, and a higher likelihood that Pectra may become two hard forks. And to that, one of the very last things, a couple of the last things that were shared on the call was around the inclusion of different SSC-related EIPs, and this is around the data serialization, upgrading the data serialization format of Ethereum. Developers are still unsure about whether or not this is even going to be added into Pectra, and based on the hesitation around changing the blob count, I don't think that there's a high likelihood of even including these SSC-related EIPs, even though implementation work is continuing to progress on these, unless Pectra is split into two forks. And then finally, of course, developers spent a couple very last few seconds on the call talking about what the name of the CL upgrade should be accompanying the Osaka upgrade. They evaluated a bunch of star names that start with the letter F, because this will be the Beacon Chain's, the consensus layer's 6th network-wide upgrade. But that's not important. Once the name of the next consensus layer upgrade after Electra is determined, I'll announce it on this show. I'll share it with you guys on this show, but I don't have any opinions or have any thoughts to share about what exactly the star name should be for the next consensus layer upgrade. I could not care less. And I think that was also kind of the general sentiment of developers on the call, too. They were like, we have other important matters to attend to. And they really do. So that's the summary. And those are my insights from the latest All Core Developers call. I hope that you learned something new about Ethereum on today's show. I hope you enjoyed listening. I will talk to you guys again for the next Infinite Jungle episode. Reminder, this will be the only episode for this week, but I'll be back with new episodes next week. Thank you for listening, and until next time, stay safe out there, everyone.